I'd like to invite our next speaker, uh, Madhu Kandasamy. Madhusudan Kandasamy is a leading artificial intelligence software development group. Um, is leading the artificial intelligence software development group at Qualcomm India. He has more than 2 decades of industry experience across AI, distributed ML, DL framework, big data processing, and Unix Linux OS development. His current focus is on optimizing AI inference on edge devices for both power and performance at Qualcomm. Earlier at IBM, he had worked on developing distributed machine learning algorithms, frameworks like Snap.ml and DDL to reduce the training time of complex networks in multi-node CPU, GPU clusters. On the OS domain operations, he developed lock-free memory allocators, malloc subsystem for OS, many Unix Linux kernel features, and system call optimization. He also has 20 plus patent grants and many research disclosures under his name. Welcome, Mr. Madhu Kandasamy. He would be talking to us on embedded AI.
Thank you, Gandhar. Hi, good evening, everyone. Let me share my slides. Okay, I hope my voice is loud and clear and screen is up.
Yep, you can see it.
Okay. Hi, good evening, everyone. So today I will talk about embedded AI, the evolution of embedded AI, and what are the use cases propelling its adoption, and what kind of challenges these use cases are imposing on both software and hardware, and how the hardware and software innovation is kind of tackling those issues. So, like many industry experts would say, AI is kind of transforming every industry, similar to invention of an electricity. So when electricity was invented, it fundamentally transformed every industry. So similar way, AI is touching all the industry, right from banking to healthcare. There is not even a single industry which is untouched by AI. And when we kind of take embedded AI segment within those industries, there are 3 pillars which is kind of predominantly impacted or improved by AI. One of the main industry is mobile, followed by industrial IoT. So the industrial IoT segment is latest innovation in the computer vision makes a lot of factory automation really possible. Like if you look at all the car manufacturing industry, majority of the hardware pipeline is automated by the robotics. And if you move on to auto industry, not just self-drive cars, or in the mid-segment cars itself, we see a lot of AI-assisted features nowadays, starting from virtual assistant to take care of the jobs through voice command, like open up Google Map or target to some specific location, create a map to that location, and even for the assisted parallel parking and stuff. These things becoming very common in the auto industry for both the safety as well as entertainment. And moving on to mobile. So mobile is one of the very ideal platform for AI-based use cases because it has a lot of inbuilt sensor and it has a high processing power. And on top of it, it has a very pervasive adoption across all the people because everybody has that mobile. So, and AI is enhancing a lot of capabilities in those mobile with the AI features like computer vision, voice recognition, speech processing, and natural language processing. So these all these features is kind of making the experience with mobile is very enriching. And the earlier days, the AI was already there in the mobile, but during those days, majority of the AI processing was offloaded to the cloud. And nowadays, with that, all the processing which you have been doing in the cloud is moving to the on device itself. One use case everybody could remember is this. A Google Assistant or a Siri, those assistants. So they used to do this NLP processing, voice recognition back in the cloud, and then you need both connection and also the cloud processing and cloud processing API to call it, which will do the translation. Now those things is kind of moving to your on device so that you get a better experience with a low latency. And not only that, moving those use cases to the on device improves your security, because your data do not move away from your device, and also improve the privacy. And you don't need to have a network connection every time to use the AI feature, because it is processed locally here. So you have all time, always availability is there. And the cost is also getting greatly reduced by moving those AI processing from your cloud to the edge. And if you look at the list of phone applications, so we have two segments of AI application in the phone. One is coming from this OEMs, which enriches a lot of AI-based processing on both camera and audio use cases. If you take the camera use cases, majority of the mobile phones now come up with a camera, so which specifically enriches the photos you take with that camera by removing the noise, improving the texture, and providing different effect on those images you take. And when you move to audio, the noise cancel and echo suppression becomes a very common use case among them. And when you go to the regular applications, the application is kind of coming from this app developers and ASVs as well. And majority of the applications, mostly this video and audio processing application, has a very good number of AI use cases. If you take Snapchat or TikTok, a lot of AI-based filtering helps to give a better engaging use of those applications. And when you move to the video side, you have this super resolution, and it will also try to identify what is the action you are doing with this video. So it will kind of try to use the segmentation and summarization of this video. And with those additional sensors, there is new use cases coming, which will monitor your health, how much you walk, and stuff like that. So because of those multiple sensors and compute, we see a tremendous increases in the AI-based use cases for your mobile phone as well. And on top of it, you have this gaming, which also which also needs some of AI-based processing as well. And if you specifically in case of mobile, all different IP blocks, which used to be a separate blocks, is kind of already moved into a single SoC. That's kind of the thing which happened in the last decade. So which makes this whole processing capability to consume a lesser power, and works within the specific thermal budget and the very small form factor. So these are all the kind of the propelling factor which made a mobile is the most popular device for AI and use. So let's take some interesting use case in mobile, and then see how AI is applied there, and what kind of expectation it puts on both the software and hardware of those mobile. So in this specific use cases, we will see how AI can be used to do automatic translation of language in a live speech. So when, let's say in some use case, if you're talking in English and the other person need to kind of listen it in Chinese, we can do this kind of AI solution to automatically do the translation. So when you speak, the audio is kind of going inside the mobile, then it goes to the sensing hub. Then in that sensor, it detects a particular keyword, and then it knows, okay, it can do some automatic translation for the destination. So then it goes to then a separate neural network, which will convert your audio. First, it will remove your echo, noise reduction, those things it will do. After that, it will do audio to text. So then all your audio will become a regular text. Then it will get applied to another deep learning neural network, transformer-based network, where whatever you talk in English, it gets translated to a different language. In the specific case, we can talk about how the English can be translated to a Mandarin. So once this text is translated into a Mandarin text, then it will go to your next neural network. So that will convert this text back into audio, and then it can go for another network, which will make the audio feel like a regular human voice rather than the robotic voice. After that, it reaches your modem, and then your converted audio goes away from your mobile. So on the receiving side, the person really listens to a conversation which is spoken in Mandarin language. So then the same thing will happen on the reverse side as well. So this way, this combination of these multiple neural networks can give one enriching experience of how two guys, without having a common knowledge, a common language, and the translator can seamlessly speak without much of an effort with the help of these multiple neural networks. And another use case, if you kind of look at this camera based, this is one of the snapshot of a chameleon without any AI based processing. So this is how the camera typically used to be. Now with AI based cameras, you see the photo is kind of a bit enriched, but what's going in background is the raw photo goes through multiple filters or multiple AI models, which kind of segments these picture into different segments and identify what kind of segments are those. What is a background? What is a foreground object? Whether it is a scenery, a green scenery, or it's like a different landscape. So based on it, it applies different color segments to each of those segments to make this picture really look better. And this needs a processing power for each of those neural networks. To move from the previous picture to this picture, you would need 4 neural networks with 5 TOPS of processing power is needed to have this kind of AI improved picture. And if you kind of take this further and move it to a video, then you need to apply this neural network in a loop for up to 60 FPS to have a smooth transition. And then we also need to have additional neural network to take care of this video transition as well. So it kind of proportionally increases the TOPS, but at the end of the day, it gives you a really nice video you can get without any expert knowledge on using these cameras. And if you take this further, if you go to this XR domain, you see that you have to have these things done for both eyes. You have 2x of compute. And not only that, there is a lot other sensors you need to take care of into the XR, because you need to know which direction you are facing, what kind of movement you are moving, where is your hand, what kind of action you are doing with your hands. All these things need to be kind of understood in this XR so that it can provide a proper intelligent virtual view. Like, I don't know if some people might be aware of this HoloLens from Microsoft. So with that kind of use cases, you need to kind of really have a more compute power, and also need to have multiple sensors to understand things, to kind of have a holographic image projected in front of you, which you can interact with. So that is the kind of the trend we are seeing in XR, which is all based on AI with more compute power requirements. So what kind of challenges it poses on both hardware and software? So that's our next segment of discussion. So I think one thing is which comes pretty obvious is it needs a lot of AI horsepower. Even in the previous couple of examples, we see it has to go through a lot of neural networks, so which needs more processing power. And any use case if you see, so fundamentally what it happens is it doesn't see it as a stream of bytes or bits. So in case of the photo, previously it used to be just a set of pixels with color codes, but now with AI, it clearly understands what that picture represents, what is the focus object, where it is taken. So all those things, it really understands from that picture and what are the objects are there in the picture. So it makes understanding of this picture. When you talk, it's not just the audio bytes. It really understands what you are taking, what is the meaning of your talk, how it can translate. So it goes beyond a stream of bits and bytes in case of AI, which gives very intelligent experience and use cases to this user. And then if you take this, so this 2 use cases we have seen, that is kind of, it is on-demand use cases. You take a photo, then this AI gets triggered. And there are few use cases which needs always on. See, for example, if you wanted to have some application in your mobile, which has to detect if the child is crying. If the child is crying, you want to send the alert message to the parents or who were registered for it. So if you want this kind of application to be developed as a mobile app, then you need to always listen to the audio signals. And even this virtual assistant where you got to say, okay, Google, hey Siri. So there also it needs to always listen to this audio voice. So these kind of things, you will not give an opportunity to shut down any IP blocks. It has to listen always, and we need a lot of low power requirement in these kind of scenarios. So if we kind of sum it up, these use cases, majority of the use cases needs high performance and need to work on complex concurrent scenarios. And all the use cases invariably needs a low power. And to get the low power, you need to shut down some IP block or reduce the speed, which may not be possible because you need a peak performance. And on top of it, you need to keep those IP blocks always on, which is also another a big challenge in the mobile space with respect to the hardware. And then moving on to the software side, this AI segment is a very happening segment. There are a lot of new frameworks keep on coming on every other day, and each framework has one advantages over other. So there is not one compelling winner on it. So we need to kind of support multiple different frameworks for different kind of scenarios. So because then a lot of new neural network architecture is keep coming on. So how do we take all these different framework and neural network architecture and make it available on our edge software? That is becoming a big software level challenges. And not only that, these software also need to be optimized very well for your edge device, because edge, if you wanted to save power and get high performance, high power hardware alone will not be sufficient. It needs both a better hardware and a better software. So in the next segment, we will talk about how the innovations in the hardware and software kind of help you to overcome both the challenges in these two segments. So moving on to the hardware segments. Okay, so we all know we need high tops. So to achieve the high tops, we can always come up with. I'm struggling with my. Okay. So on the hardware side, to get the higher tops, we can. One way is you can get a more number of CPUs, but obviously that is not as scalable. Then people might be aware of GPUs, so that will try to do a lot of parallel processing, and it is kind of predominantly done for graphics, and then later it moved to the machine learning side on the training aspect of it. So from the embedded AI segment, we need some special processing engine to take care of efficient execution of these deep learning models. When you split between the AI between the embedded segment and the regular AI in the cloud segment, most of the embedded AI segments are built upon deep learning use cases, mostly on computer vision and other things. So once you come to this deep learning use cases, even the deep learning also, it is not both training and inference. Majority of them is only on inference is happening on the embedded use cases. So if you drill down into the inference on the deep learning, it's nothing but a forward pass on a set of weights and biases. So it just, when you do a forward pass, all it does is it takes the activation, multiply by the weights and adds a bias and applies some activation algorithms at the end. So that's the fundamental or common most common denominator across all those use cases. So it makes a lot of sense to come up with a new silicon or a processing engine which will accelerate that specifically for AI on top of the existing CPU and GPU. So that is what you see the trend in hardware. And if you take our Qualcomm example, we have a hexagon processing engine which will provide these kind of accelerators. So this accelerator will has both tensor and vector and scalar accelerators. So this tensor accelerator will try to help you to get all your matrix operations much faster. And then the scalar is similar to your CPU, which will help you to kind of do all the arithmetic. And then vector will try to help you to do the SIMD kind of processing with the vector processing. So all these three units put together called a accelerator engine, which will help you to accelerate your AI-based deep learning forward processing much better in the embedded device. And then if you kind of move to the software side, so Not sure whether my slides are properly. Okay, so I think there's some part of the side that I will still go on. So on the software side, if you look at it, uh, we have a varied set of open source software available, which will help you to do the training aspects of it. Now, when you try to do inference on top of it using using the embedded device, you need to have a separate custom on-device SDK. So if I take an example of Qualcomm, so we have a execution engine SDK called Snapdragon. So this will help you. This is one of the on-device SDK, which will help you to do those acceleration much faster. If you kind of look inside it, so you have training which will be done on a very number of different open source framework, and you get a model, and then you do a proper regular training, which will help you to get those model in a much accurate way. Once you receive that model, then you come to this on-device SDK. So this on-device SDK has two parts. One is pre-processing part, and one is the inference execution part. In this pre-processing part, we have a support for multiple different open source framework and convert it into a common internal format. And then you take this internal format. This internal format is it has a compressed model which you are trained on the server side. Then you kind of push this model into your SDK, and then you do inference on top of it. So these kind of on-device SDKs will help you to easily use all the open source, different kind of open source train network run much better on your edge devices. And there is another kind of software which will help you to directly access your hardware compute. So one of the software is called AI Engine Direct. So this is kind of a thin layer on top of each of those compute. So if you wanted to do some processing on, let's say, this AI processor, then you can build your software stack on top of this AI Engine Direct, which will provide the list of operations for you, using which you can build your neural network. So this, like for example, your Snappy, you kind of build on top of it. If you have some TensorFlow, PyTorch, everything can be built on top of the direct engine. So it gives a very direct access to your engine in a much faster way. Okay. So then this is about your on-device SDK, which will help you to run your application be trained on multiple different open source network. Then other set of technology which will help you to improve your power and performance is called quantization. So what this quantization helps you is, if you take your existing model trained in the open source framework, so that will have a bigger network with lots of weights and biases in floating point. So first you need to kind of compress this network into a smaller size. So you need to do some forward cross to identify what are all the dead neurons are there. What are the neurons you really don't need to use to achieve accuracy. You can remove them. You can remove those layers. So that kind of tuning you can do. So in the next step of optimization we can do for embedded devices, you can compress those floating points into a integer numbers. So if you take the same range, a floating point range, and then convert all the weights to a same bucket from X range to Y range, a proper correlation between each of those weights and biases, then you should be able to achieve a relatively better accuracy with much larger reduction in the model size. So that way you can save a lot of power, because integer operations is way cheaper than doing a floating point operations. So this AI model efficiency toolkit or these kind of quantization softwares will help you to convert your float based models into integer based quantized models, and these models is really small in size, which can be easily put onto your on device. So this way you can improve a lot of performance and improve a lot of power utilization metrics. So I think now we try to kind of summarize it. We have a major problem with high compute requirement on hardware, and then we have versatile open source softwares needed, and then we need to improve our performance. With the hardware, with the AI processor, we will get a lot of tops and power efficient operation of the hardware. And when you come to software sides, we have on-device SDKs similar to the one which I give an example from Qualcomm. These on-device SDKs will help you to write your accelerated implementation of those AI operations. And then we have this quantization technique will help you to optimize your models to improve your performance on your on-device computer. Yeah, I think this is what I was kind of planned to cover for this talk. Maybe I can take some questions, if any.
Hi, Madhu. There is one question from the audience. What are the already implemented AI use cases on embedded systems which are available for public use right now?
There are multiple use cases available. I think you just need to Google and look for some open source projects. I think majority of them, if you go for TensorFlow, there is a separate directory called research models in the TensorFlow GitHub. And then you have this TF Lite GitHub available, where all Google implemented a lot of many AI algorithms, but you need to build your app on top of it. But the core AI algorithms, you have reference implementation available. And then if you kind of enroll yourself to the developer AI summits, when the people kind of present it, many of them will kind of give a reference to the POC implementation of their new neural network. So you can fetch onto it to implement your embedded AI-based applications.
Okay, thank you very much, Madhu, for your insights on embedded AI, and it was great to have you at the IESA Vision AI Summit. Thank you.
Thank you.